Great, thank you for the introduction, Manny. My name is Laura. I'm a software engineer at CodeShip. I primarily work on the Docker backend build platform, and for the next 45 minutes or so, we'll be talking about efficient parallel testing with Docker. And as Manny said, I'm a Docker captain, which means that I've been working with Docker for a long time, and I have given lots of conference talks and written lots of blog posts about different cool things that you can do with Docker. All of the Docker captains are really excited for people who are new to Docker, so if you have any questions or you're a newcomer to the Docker world, find one of us and ask us a question, and we'll be really happy to answer it for you. So as I said before, we'll do about 45 minutes of presentation and then just about 10 minutes of Q&A. And you can ask a question in the GoToMeeting questions panel. And throughout the talk, Manny will be kind of filtering through those questions and answering the ones that he can with links to documentation or whatever else is necessary. And then we'll save some time at the end and I'll answer the questions that are remaining. We'll split up our talk and our time together into three big chunks. The first will be understanding the goals and benefits of parallel testing, why we want to do it, what kind of platform we're talking about when we talk about parallel testing platform, etc. We'll look at an implementation using LXC alone, and then we'll look at what implementing a parallel testing platform looks like when you have Docker and the Docker ecosystem tools. So let's get started with parallel testing. And the goal, the thing that we're trying to create here is a customizable, flexible test environment that enables us to run tests in parallel. So speeding up your automated builds by running things in parallel isn't as easy. It's just kind of writing some configuration files. You have to have a platform that enables you to do it. And that takes a bit of work, but it's definitely worth it because there are lots of benefits of running your tests in parallel and having a much faster build cycle. The first one is pretty obvious, it's speed. So you want to spend less time waiting around for your builds to finish and more time coding. This has a couple of benefits because it means that you can ship code to production faster and your customers and users can always have the best stuff in front of them. And on the other side, you're also alerted more quickly when tests fail and when there is a problem. So by making the feedback loop a little bit shorter, you can get more work done and be more efficient. So if you're not sure that testing or software testing is important to the software development cycle, this webinar may not be for you. I'm going to operate under the assumption that all of us here understand that software testing is absolutely crucial to delivering quality software. And what we'll talk about today are ways that it can be better and faster for your team. So if you're not sure that software testing is a good idea, I'm probably not going to go into much detail about why you should do it. I'm just going to talk about the how you can make it more efficient for your team. So speed is one reason that we want parallel testing. And the second is that with the platform that we outlined in the goal statement just a couple slides back, in this environment, this customizable environment, developers can have full autonomy over every single thing that happens. So this includes deciding which testing command should happen in which pipeline. It can mean designating commands to be serial, to run in parallel, etc., deciding what time they run. And then also the engineer should have absolute control over the dependencies for each testing service. So if you want one service to run with a dependency of a specific version, you should have total control over everything that's running in your build environment. The goal is not to provide a cookie cutter environment for everyone to use. The goal is to allow engineers to customize a highly specific build environment suited to the needs of their application and their testing tasks. And if you were at DockerCon, this slide probably looks familiar. It was during Solomon's keynote, that the point is that by allowing you to have parallel testing and parallel build pipelines should really reduce friction in the development cycle. So I believe that CI and all of the automation steps, there's a reason that you automate them. It's to get them out of the way so you don't have to deal with them. You should set them up once, and then they should run and be self-sufficient. And that's really the goal here, is to reduce friction in the development cycle so you can spend more time working on what you want to work on, which is probably not fiddling with broken builds on CI. So given all of this, there's a couple of places where this parallel testing system might be implemented. You can use a system like the one I'm describing for local testing. So for example, if you, you're an engineer and you're working on something, you probably, and you should be writing unit tests and integration tests for the features that you are building. And some of us like to run tests on those things before pushing them up to a feature branch on whatever source control you use. I happen to like GitHub, so I'll probably use GitHub as an example. So before I push to GitHub, I always want to run my tests to make sure I'm not going to trigger a build that's going to be read and kind of waste everyone's time waiting for a build to fail when I could have checked it beforehand. Of course, that takes time, and I'd rather have that done faster, so that's a place I could use parallel testing. If you build your own CI or CD system, you might want to implement a pattern like this. And of course, there are CI and CD solutions that are hosted that have implemented things like this. For example, CodeShip, which is why I have authority to talk about it, is because I helped build it. How are we going to accomplish this? This is the fun part. So given a series of build tasks, what we want to do is split up the tasks, give developers full control of dependencies per task. So this is sort of moving the task to be the top-level citizen and then orchestrating everything around the tasks. And then we will use containers to run multiple tasks or multiple tasks at once. So the container is really an implementation detail, but it allows us to do some interesting things. And what we're going for and what we're aiming for is something that looks visually like this, where I as a developer work on code. Maybe I have a feature branch that's then merged into master, and then that's going to kick off some kind of automated build. And we can see in this example there are 4 testing steps, and they're all happening in parallel. But they have one outcome, which is a green build. So if any one of those steps were to fail, of course, we wouldn't have a green check, but we'd have a red X. This helps us get really fast feedback because those 4 tasks are running at the exact same time. So if they were running serially, and let's imagine each of them takes 2 minutes, then that'd be 8 minutes. I'd rather wait 2 minutes than 8 minutes. So parallel testing can help reduce a lot of time and friction in your development cycle. And the way that we're going to, I guess the theory behind the way that we'll implement this comes from good old computer science. And if you are a CS person, you've probably studied parallelism a lot. I'm kind of borrowing a bit from the traditional definition of parallelism, and we're going to use something called task parallelism, which is running tasks across multiple processors in parallel computing environments. So this is not the somewhat more common definition of parallelism, where we execute parallel computational tasks against the same data set. It's more splitting things up and running them in parallel computing environments. And in this case, containers are our parallel computing environment. So again, this is called distributed task parallelism. And in this example, the container is what's allowing us to achieve our goal of building a flexible, reproducible build environment that's going to allow us to do parallel testing. And the only reason that we can kind of advance and start to think about containers this way is if we stop thinking about them as just like substitution for a virtual machine and start thinking of them sort of just as a process that can run some work for you. So if we think of a container just something that can execute some unit of work, we can split our automated builds up into many units of work and then have a container execute each unit. That's really the heart of what we'll do. And you might ask, like, well, given that definition, why not just use VMs? And there's a couple, I hesitate to say problems with VMs, but maybe a couple undesirable things and things that are just a lot harder to do with virtual machines rather than containers. And especially if you have a shared build system, maybe a multi-tenant or multiple teams working on an internal build system that you've built for your own internal use. We really want isolation of builds running on our infrastructure. So we don't want Team A to be mucking up something that Team B is running. And we found with VMs it was a little bit harder to isolate things aside from just having one VM per build or per team. We wanted something a little bit more flexible and elastic. And dependency management was also not the most fun. to manage just using VMs. It's certainly made a lot easier with containers, especially Docker. There is not really a great clean interface for imposing resource limits when you're only using VMs. And I think the most important thing is infrastructure is underutilized, which makes it really expensive. So if you have one very, very small testing task and you are running it on even, a smallish VM, you're probably wasting 90% of the space on it. You're paying for that wasted space, and it gets really expensive. So virtualization density is often the term that people use to talk about how utilized your infrastructure is. So using VMs only and running one task on them is a pretty low virtualization density, whereas in the world of containers, maybe you could run 100 tasks in the same on the same VM, and you'll be given isolation and all of the other good stuff. So it's an easy way to sort of change the way that you think about accomplishing work that can, in the end, sort of save you money. So of course, given all of the things that I said about VMs not necessarily being a perfect match for the job that we have set out to do, containers seem like a really, really good way to get all of this accomplished, and in fact they are. So with containers, it's really easy to impose resource limits, increase virtualization density. So again, using our infrastructure more fully and not wasting money. We can run customer code in isolation with containers really easily. And the really great thing when you bring in a service like Docker is providing consistent build environments across many build runs because of the way images are packaged and distributed. And of course, all of this is going to lead us to a system where we can run tasks in parallel, and that's what we're going for. So I want to talk a little bit about the sort of the first implementation of parallel testing that we did here at CodeShip, which is LXC based. So if you're a CodeShip customer, you may not know, or you may not have noticed that CodeShip has been powered by containers since the very beginning. If you are using anything on the classic infrastructure, so the non-Docker infrastructure, you are using an LXC-based testing platform. This is really, really well suited for users who first of all, aren't using Docker or aren't using Docker yet, or who want just like a one-click test environment without too much customization. So of course, there's lots of stuff you can customize, but it's not nearly as fine-grained, customizable as something using Docker. And we sort of compromised that flexibility and that granularity of control for ease of use. So it's pretty easy, and there's a pretty low barrier of entry to get set up on Checkbot, the CodeShip Classic infrastructure, but you don't get as fine-grained of control as if you were to use our Docker platform. This is like a huge workhorse. Checkbot does a lot of work. So about 40,000 builds per day. That's sort of like a high to average number, I guess, and then overall almost 8 million builds per year. So this is not just some little pet project that we decided we'd try out LXC. This is kind of what pays the bills for CodeShip, and it's certainly the most popular offering that we have so far. So a bit more about the architecture of this, because that's sort of the interesting part. So like I said, this is implemented with LXC, and basically what happens is that each build or each build pipeline is provided this universal container that has dependencies in it. And for each virtual machine, we allow a certain number of containers to be running on that virtual machine. So it's less of an elastic kind of scale up, scale down like you might imagine Docker, and more of sort of just slots. And there's a fixed number of slots that are on each machine, and then you kind of check out a slot, run your work, and move on. But because these are still pretty modular, like just checking out a slot, it did allow us to implement a parallel testing pattern using parallel CI, which is something that we offer with our classic infrastructure, where you can have N pipelines that run in isolation during a build. So for example, if you are a Ruby on Rails developer and you have RSpec as your testing suite, and then maybe you have some linting stuff like Rubricop running, you might want to run those in separate pipelines, and you can do that with parallel CI on the classic infrastructure, just using LXC. So no Docker, but just using LXC. What this looks like visually a little bit is that we have these pipelines, again, so this is like your unit of work that you want to accomplish. This could be RSpec, it could be a linter, it could be something else. That pipeline has a universal container which then runs the commands. And you can have n pipelines theoretically. So let's say you have 5 pipelines. Once all 5 of those have completed successfully, then you might kick off a deployment to a deployment provider. And with the checkbot, CodeShip Classic, this is all included. It's kind of like a point and click situation where it's really easy to get up and running with this. Some limitations though with the system, and you probably can think about the first point there, parity between dev and test. So again, I've been using Docker for a really, really long time, but I'd never run a non-Docker application in LXC for my job. That's not something I've ever done, and I think most of our customers probably don't use LXC in development either, and probably not in production. So it is kind of not ideal to have testing tasks running in LXC because it can make it really hard to debug locally. This is solved by allowing our users to do a remote SSH session, like a debug session during the build to see what's going on. But it would be much better if it were something that were a bit more native to the developer's workflow. There's also no great interface between user and container. So between user, whether that's us or the actual user, and then the LXC container that's running. It's not the easiest thing to interact with. And then resource consumption was just too high because we are still kind of provisioning a fixed amount of space for each of these pipelines to run in. So the LXC universal container is uniform, and we're not really scaling it up or down based on the needs of the customer. And we are one of our biggest customers ourselves. So with this, with the CodeShip Classic infrastructure, although it's still a really, really great solution for so many people, as we became more interested in Docker and as we sort of started using Docker more and more, it became clear that Checkbot and LXC just wasn't going to get us into the future in the way that we needed to. So we weren't able to build the most efficient product for our customers or for ourselves. We knew that we would have to do something a little bit different. But luckily, just around the time that that we were feeling that maybe we wanted to make some updates, Docker kind of hit the scene. So enter Docker in the Docker ecosystem, and we were able to do some pretty cool stuff. So again, the goal and what we're building here is a flexible test environment that will enable us to run tests in parallel. And the big wins with Docker that we got pretty much out of the box were support and tooling, standardization, and then also a community of really motivated developers. So it was really clear that Docker was something that people cared a lot about and that people wanted a lot. And we knew that if we could build a system to use Docker, that we would be helping out a lot of developers. So we were able to build a much, much better testing platform with Docker and the tools that Docker provides than with LXC alone. And what we built is a brand new product. So we chose not to extend Checkbot. We chose to just build something new. It's called CodeShip Jet, and you've maybe seen this cute little jet cartoon around our website. It is our main Docker product. You may have heard of it called the Docker platform, or CodeShip's Docker platform. So this started about, 2 years ago, 2014. We released the first beta in 2015, and then just earlier this year, in February, it was the official launch. So we started, 2014, if you think of where Docker was in the world, that still didn't have as much steam behind it as it does now. And I think it's sort of proven its worth, certainly now in 2016, how many people are using Docker, especially if you compare the first DockerCon in San Francisco to the one that just happened last month. It's pretty remarkable to see how many people have adopted it. And the thing that's really different about Jet is that not only did we build Jet with Docker, so myself as a developer, I use Docker to build this tool, but we built it in order to natively support Docker workflows. So really the fact that it's built with Docker is sort of an implementation detail that makes my life easier, but isn't necessarily visible to those of us that use it. What is visible is that we designed it specifically for people who are using Docker. So we made the assumption that you're using Docker in development and in production, and we'll fill in the gap to use it in the test step as well. And Jet is gaining a lot of momentum. So again, it's still a pretty new product. It just officially launched in February. I think actually this number 2.3 thousand builds per day is a bit outdated. I think we're closer to 2.5, and then around 250,000 total builds. So we're moving along, and the number of builds are increasing nicely, and the system is scaling pretty well, which is always good. Always good to see as an engineer. A couple of the Docker tools that we chose to incorporate into this project, there's 3 of them that make a huge difference. The first is Docker Compose. And if you've used Docker Compose, you know that you sort of define a list of services, and we borrowed that service syntax and in fact incorporate it into our step definition syntax as well, because lots of people are very familiar with using Docker Compose. You can also just borrow your Docker Compose service file, so Docker Compose YAML, and use that directly with Jet CLI running locally, which is really handy. We support the Docker registry natively, so we have a type of step that's specifically for pushing to the registry. And we previously used the registry as well for remote caching. I'll talk a little bit about how we handle performance and specifically image caching and speeding up builds a little bit later after the demo. Docker for Mac and Windows is also a really, really great addition to Jet and to our users, because it makes it really easy to use Docker locally. And we have the Jet CLI, so you can use the hosted version of Jet where you push to GitHub whenever we receive a webhook and run builds for you. You can also download the CLI to run things locally, which is really helpful for debugging and reproducing your CI environment on your local machine. And the workflow kind of feels similar to the first diagram that I showed you when I first introduced the idea of parallel testing. You push code, we look at your services file, the steps file, we start building what we need to build. We split the tasks out into different containers or groups of containers based on how you've declared them. We run the tests, and then maybe we push to a registry as your deployment step. You could run a different deployment step if you want. But pushing to a registry, again, is a supported and kind of first-class action with Jet. So it's a separate kind of step specifically to push to any kind of registry. So whether you're pushing to a registry that you're hosting yourself, if you're pushing to the Docker Hub, any type of registry you can push to. The workflow tools that Docker provides are indispensable. And if you're not using Docker yet, this might be the thing to kind of tip you over to use it, because Docker is not just a really great application for shipping and running things in production. It's really, really good as a developer to have really, really great, well-designed workflow tools at every part of the development process, whether it's development or production. So I use Docker all the time, not just saying that because I'm a Docker captain, but I really love Docker, and I really love using it in my everyday development workflow. So let's talk a bit more about actually testing things in parallel and what it looks like specifically using Docker and containers managed by Docker. So we were able to not just change the way that we are running parallel tests, but we actually kind of changed the way that we designed the entire system, because containers are so much easier to manage with a tool like Docker versus trying to manage LXC containers by ourselves. So we were able to extend the parallel workflow that we introduced with Parallel CI and the idea of N pipelines. Each of those pipelines was scoped to the same service. And what we were able to introduce in Jet is the idea of a service itself. That's something that you can define. So you can have multiple services and multiple steps and kind of mix and match what service and what step should go together. So you can execute N steps against N services. So you can highly customize exactly what you want to run, and then what task should be run against the service that you're running. And again, we also introduced the idea of time control or time series control. So you can define parallel or serial steps and group them and order them in any way. You could have a group of parallel steps that itself is a serial step and then has another serial step happening. So there's sort of an infinite configuration of services steps and then time sequence of parallel and serial. A service can be something that's either pulled from a registry or built from a Docker file. You can, because you can define them independently of the task, you can fine-tune the service for each task. So, for example, to go back to my the Rails application I spoke about earlier, if I have RSpec, I certainly will need my like Rails application, my web app, and I'll need a database probably, and maybe Redis or something. If I'm running a linting task, though, I really don't need a database to do linters. So I can have one service that's app that has my Rails, like my Ruby code, and it has my database and Redis or whatever else I need. That can be one service. And then I maybe can have just a separate service that's called just Ruby that I can run my linters against. There's no reason to have a database for something that really doesn't need it. And it's this customization that can make this system really performant for specifically your use case. Steps are the cool part. I really like configuring steps for new projects that don't have CodeShip, that you know haven't worked with CodeShip before, because I think it's fun and exciting. So each step is executed in an independent environment. So if you have two steps executing in parallel against the same service, that will actually spin up multiple clusters of the service. So you'll have step one against its own environment of a service, and then step two will be running against its own environment as well. These steps can be, as I said before, nested in serial and parallel groups, and then you can run a command, so run your testing suite, and then the other type of step is a push step, which is pushing something to the registry. One super cool thing about steps is that we support tagging, so we will match the tag that you specify, do like a simple regex matching to only run steps on certain branches or tagged releases. For example, you might not want to deploy to master when it is, you might not want to deploy to production when the test that's running or the build that's running is not a master branch build. So you can have a tag that says only run this step if the branch is master. That way you don't have a risk of running, accidentally deploying code from a feature branch when you really don't want to. A bit visually, the difference between what I just described with steps and services versus what we had been able to implement with LXC alone. This is an example of LXC, and if you're not familiar with like time sequence notation, the T1 means like first point in time. So in this example, everything's happening at the same time. Again, the LXC implementation was just sort of slots that could execute some unit of work. So we have these units of work and they're happening simultaneously, but there's no control over the time sequence and there's no control over the service. You can only control the command. In the red box, it's the only thing that the user has control of in the system. When we enter Docker, though, we can control basically everything that you see here. So we can see we have 3 different points in time, T1, T2, and T3. At T1, we run one step. T2 is the second step in that serial sequence, but you see that it's actually a parallel group step. So we have 2 steps running at the same time in parallel for T2, and then provided those are successful, we'll move on to T3 and work with a totally different step and a different service configuration. So you can control things on sort of multi-level fine-grained control of your build system using Docker with Jet. Here's an example of what a services file looks like. All this really cool stuff might seem like you're going to have to do a lot of coding and a lot of configuration to get it to run just like you want. But I can tell you that it's not really that's not really the case. We use YAML because we wanted to give the user something to that's human parsable. So you can read it easily, you can comment it do whatever you want. And if you're not familiar with YAML, just the main important part are these top-level things. So each of these, database, app, deploy, these are the service definitions. So I have 3 services in this example. I have a database, which is pulling an image down from the Docker Hub. I have an app, which is actually being built from the Dockerfile test, and that's linking back to the database. And then I have a deploy service as well. We'll talk a little bit more about why having a deploy service is probably a good idea, but this has some Docker configuration encrypted, so my login credentials in order to push to the Docker Hub. And I also have a separate Docker file for it, Dockerfile deploy. And then we can match that up, those services, so keep those in your head. Those are going to be referenced directly from the CodeShip steps. I just realized I have a mistake on the title of this. This is CodeShip steps.yaml. So this is a group of 2 serial steps that contains a group of parallel steps. And if we look at the serial steps, sort of we'll look in we'll go in to out. So we have the first serial step here, the second serial step here, and then within that first serial step, we have a step group of parallel steps. So that maybe is a bit confusing, and there's a lot of really highly customizable stuff, but we have basically 2 steps. If this parallel step group succeeds, then we'll move on to the deploy, but only, again, if it's master. We have that tag down there. So this is an easy way to make your testing feedback cycle really quick. So everything in the square is happening in parallel. If anything is wrong basically with my code, I'll know it right away. I will not deploy. I won't deploy if any of those parallel steps fail, and I also won't deploy if it's not master. So I'm able to kind of control every single thing that's happening, service-wise, time-wise, and step-wise. Here's a pro tip. You have full control over everything. Please don't make your push step or some deploy step be part of a parallel step group, because there's no guarantee that the deploy won't finish before a parallel step will fail. So you might, you don't want to try to over-optimize this and say, oh, well, I'll just do everything at once. That's not the goal here. The goal is not doing everything at once. The goal is cutting down time where it's appropriate. So run your tests in parallel, wait until all the tests pass in order to do a deploy step. And with that, let's look at some code. So I just have a really simple Rails application here. It is called my Notes app, and it's just a list of to-dos and tasks and other notes to myself. This is a pretty simple Rails application. So I have just the bare minimum, basically, of what I need for a Rails application to run. I am copying my gem file and my gem file lock separately because that helps optimize the cache, the Docker image cache. When I rebuild, assuming my gem file hasn't changed, then I don't have to rebuild those layers in my image. And then we'll start the container with Rails-S, which is just the server command. I have this running with Docker Compose right now, and we can see that this is just a pretty vanilla Docker Compose YAML for a basic Rails application. So I have my database, which is Postgres, and then my web application, which is using this Docker file, exposing a port, mounting my working volume into the container, and then linking back to the database. And this is running as we can expect. I'm using Docker Machine right now instead of Docker for Mac and Windows. I like to have multiple Docker machines sometimes when I'm developing because I break a lot of stuff all the time. So this is my Docker host, and I'm just looking directly at 3,000 of this. So when it comes to test this application, I have made a CodeShip services file, which is nearly identical to my Docker Compose file with a couple important differences. The first being my deploy service is different. In my development mode with Docker Compose, I'm mounting a volume, but of course I can't do that when I'm deploying it. I need to actually copy stuff into it And the same for testing remotely. So it was important that I have a different Docker file. There's also some different environment variables that you want to configure for deployment that you don't want probably in your development environment, and vice versa. You don't want development environment variables in deployment. You could handle those with an external or an extra Docker, an extra environment variable file, or you can put them right in the Docker file. It's up to you. This is an easy enough example where having multiple Docker files was just totally fine. So I have 3 services: database, an app, or my web service, and then the deploy service, which again is only for deployments. In my CodeShip steps file, this is very similar, actually I think identical to the example in the presentation. So this is again 2 serial steps. The first serial step is a parallel step group. So we'll run RSpec, Rubycop, Camel, lint, and Rails best practices in parallel. And if and only if those succeed, then we run a push step. So I'm not going to run the push step here because I don't want to do that from local environment. I just want to run my testing. And luckily, if you have the Jet CLI, that's the default behavior, is to not do push steps and behave just like it's not running on a remote hosted CI. So I can run this just with Jet steps. And we can watch this spin up things in parallel. So if we remember, there were 4 parallel steps in my first serial group. And we can see them starting almost like perfectly simultaneously here. And then this can be maybe a little hard to keep track of. The thing that you want to look for is the service name here. We have my app service, which again is very similar to the app service that I'm using in Docker Compose, is going to pull from the local image cache that I already have on this Docker machine. So we'll see this kind of install some gems. Let's see. Unfortunately, Kabel Deutschland is having some connectivity issues today of all days. So I certainly hope that this will succeed. And if not, we have a backup running on DigitalOcean. So hopefully we won't have to. One thing that I want to show before, maybe while we wait for this, is just what it looks like on the hosted service when you have steps in parallel and steps that are serial. This is the Jet UI, and this is kind of a new and improved version. So we had a really big engineering effort to switch away from Angular and move to something called Vue.js. And there's a really great blog post on the CodeShip blog about why we chose Vue.js and the cool things that we can do with it. Basically, these logs can be really long, and Angular just couldn't. Angular, I guess, wasn't the right choice to keep up and display them in the browser, so we switched to something different. So the Jet UI splits things up pretty logically into services and into steps. So we have the services here at the top. These are only defined once, even if they're shared with multiple steps. So we can look at the log output for the service as it's being built. Of course, we only build services one time, unless there's a really, really compelling reason to build them more than once. And then the service that each step runs on is here in this little like info sidebar. And we have collapse, sort of this collapsing mechanism that can help you visualize how things are running in time. So we have the serial parallel group. Again, this is step 1, and then the push deploy is step 2. So within this step 1, we have a couple of things that succeeded, and then the deploy step pushed to my my image on the Docker Hub. Let's try running this again. The really nice thing is that I'm running this application in DigitalOcean with auto redeploy. I'm using Docker Cloud, and you can see I have the old version of the application. All I did with the build that we just looked at was push an image to the Docker Hub, and Docker Cloud can automatically redeploy your service for you. So we can see that I have this here for auto redeploy is on. So with CodeShip, I can do a push step, and then I can let Docker Cloud take over the rest. And as soon as there's a new image that's being pushed up, then Docker Cloud will say, hey, there's a new image. I'm going to auto redeploy the application for you. You can look at a couple of the container history here. You can also, of course, SSH into the build machine if you want to, and see the management that Docker Cloud is doing for you. So even though my CodeShip setup is really simple, I'm able to run something in production with fairly minimal work just by using a native Jet push step, which is pretty cool, and it's really easy, especially for smaller projects or personal projects or projects to demo during a talk. Okay, cool. It looks like maybe my connectivity issues were resolved. As soon as this is finished, maybe I spoke too soon. Okay, we'll give this a little bit of time, and let's talk about some engineering challenges and a couple other things about Jet before we look at this again. So first I want to mention, so I'm using Docker Machine during this talk because I like to have multiple machines, but normally I would be using Docker for Mac and Windows if I'm just developing things or if I wasn't giving a presentation, I guess. So this allows all users to test locally, and you saw the CLI for Jet, which is identical to what's running in the hosted version of your build of the UI that we looked at. And you can pull down the Jet CLI and play with it yourself at bit.ly CodeShip Jet tool. So of course the Jet CLI is totally free to download. There's no, you don't have to have an account in order to use the CLI. There's nothing to do with CodeShip really, just that we built it and we think it's cool, so check it out. If you want to run hosted builds, of course, then that's something that you'll need to get a trial for and have a CodeShip account for, but not to use the CLI. And just being able to give our customers the opportunity to run builds locally on their machines is a huge advantage over our previous LXC-only implementation. But we're not finished, of course. There's lots of really cool stuff that we want to work on. So Jet was born pre-Swarm and pre-Docker 112, which is super cool and mind-blowing. And if you are a fan of Docker and you use Docker, I highly recommend checking out all the cool orchestration stuff that comes with 112 when you use Swarm mode with Docker 112. So Swarm and 112 and new orchestration tools are it's going to provide us an interesting way to handle our build system. So right now we have our own service that manages commissions and decommissions AWS machines, basically as our fleet of build machines. And we chose to do that instead of any other sort of scaling or orchestration tool, I guess, because of concerns about security. But so like services like Karina and the security hardening that Docker has spent so much time working on, it's very promising for us to the point where security is not necessarily a prime concern anymore. So we're really excited to look at the cool things that we can do with this system using Swarm. libcompose is also really exciting for us. So right now we just use the API, the Docker API directly for any container level operation. So not only was Jet born like pre-Swarm, but it was also born before Fig was very popular and before the idea of application templating really took off. So this libcompose change is really going to be something that our engineers will be happy with, something that will make my life easier, but not necessarily something that is going to impact the users, but just makes the tool much easier to maintain. So the preliminary work has already been completed, and we're kind of chugging full steam ahead on it, and we're really excited to make some big improvements to the Jet CLI. And I guess the TLDR of this is that you can really create a highly efficient parallel testing platform with LXC alone, but if you use Docker tools, it makes it so much better and so much easier. And before we conclude, I just want to take a peek back at my struggling build, which it looks like it's okay. So let's just take 30 seconds to talk about what kind of output we're seeing here. So we looked at the build part, where we're building the service. And then we can see that since this is running in parallel, we kind of have jumbled up output from different steps. Of course, logs can't be outputting things simultaneously. It's kind of one line at a time, so we have different chunks of things. But you can see that these things are all kind of happening at the same time. We see RSpec in here as well. We see RSpec has its own database and its own application. So as I said before, each service is kind of a single instance per step. So each step gets its own build environment. In this case, RSpec has its own application and its own database. The same is true for all of the other steps. And then we should see some success notifications somewhere down here. Here we go. We have step finish, type success, step finish, type success. RSpec is still going, and then hopefully we'll see success from then. So again, each step gets its own isolated, identical build environment, and then things are run in parallel when you tell them to be run. And then before we move to questions, I just want to mention that if you want to have a trial of Jet as a hosted solution, so not the CLI, but the UI and the kind of webhook goodness, project goodness that I showed you briefly during the talk with my own project, you can sign up for a trial by going to CodeShip Jet trial, so bit.ly CodeShip Jet trial. You can also, of course, download the Jet CLI if you wanna try that out. We will do another webinar next month specifically about Docker best practices with CI and CD. You can sign up for that webinar at the URL there, and if you want to check out the recording of this webinar, Manny will send it out via email next week. So thank you very much for spending the last 45 minutes or so with me, and I will hand it back to Manny for a quick conclusion, and then I'll take some questions.
Thanks, Laura. So yeah, I hope everybody enjoyed the webinar, and you saw that Laura showed you how to set up parallel testing for Docker apps, and we talked about why our initial LXC setup could not provide as much flexibility and efficiency as our Docker setup, and what our thinking in detail was behind building our new Docker CI platform. And if you're interested in CodeChip Chat, as Laura mentioned, you can start a conversation with us anytime. You can request a free trial. You can read the documentation about it. We highly encourage you to check it out because it's really powerful, and we are proud of what we have built there. And we think that this approach with the workflows it enables and the processes it enables is really the way to go in the future. So as Laura mentioned, if you want to sign up for a free trial, just follow the link on the slides. I also posted it in the chat panel of GoToWebinar with some other helpful links. So yeah, we hope this webinar was helpful to you and that you liked it. And as mentioned, we already defined our next webinar on August 25th. And it's our CodeShip success engineer, Ethan Jones, and he will talk about CI and CD with Docker. He will give a basic introduction and some best practices how to set this up. So it will be a good step-by-step guide on how to get started with continuous delivery pipelines, automated testing, and how to set all of this up. So feel free to sign up at the provided link, and we hope to see you next month again. And now back to the Q&A session.
All right, thanks, Manny. So I have a couple of questions. So the first one is, what's your typical unit test code coverage on your pipelines? Whether you guys write a lot of functional automation to front end, RSpec, et cetera, et cetera. So I guess for CodeShip, we are huge fans of automated testing and not necessarily TDD specifically, but that we should have very, very solid test coverage. So I personally feel that 100% test coverage is the only acceptable percent. So it's either 100% or 0%. You can't, like, testing can't tell you that your code works. That's just not what testing does. It tells you when it's broken. So if you have 80% test coverage, you might as well have 0 because there's no way to guarantee that it's not broken.
that's how I feel. So certainly parts of the CodeShip application aren't 100%, but that's what we strive for. We write all different kinds of tests, so we write a lot of languages. We have Golang, JavaScript, Ruby, etc. So any type of test is always appropriate, and we try to have as much coverage as we possibly can. The next question is, can I use Jet with my running Jenkins setup, or do I need to migrate to CodeShip solution? So I have gotten this question a couple times, and maybe you can use the Jet CLI with your running Jenkins setup. Like, that might be something that you could do. I couldn't necessarily tell you how to do that. CodeShip and Jenkins aren't really designed to coexist. CodeShip is essentially a competitor for Jenkins, so we do the same work, so there's not really a point in having Jenkins and CodeShip. The main benefit of CodeShip is that you don't have to set up Jenkins. So I know setting up Jenkins and maintaining Jenkins is not one of my favorite jobs. That's why CodeShip is a really great place to work. We don't use Jenkins at CodeShip, we use CodeShip. So I would guess my short answer is you should migrate to CodeShip instead of trying to get Jet to work with Jenkins. The next question, is this repo public anywhere to look at the setup? So my notes application is not yet public. I will probably make it public. There is another public repo on my personal GitHub that has actually two very similar Rails applications, one using Postgres and then one using SQLite in the same container. And it shows you how to use linking and communicate between two containers that are like a database that's a dependency for a web application. So you can check that one out, and I will clean up this repo a bit and then make it public. Does Jet work with Docker Native on Mac OS? If Docker works, Jet works. So Jet just needs access to Docker on your machine. So if you're running Docker, then you can use Jet. Let's see, clarification request with Classic uses separate AWS instance per pipeline. So I'm sorry if I was unclear. It's not a separate AWS instance per pipeline. A pipeline is an LXC container, and there can be multiple LXC containers on a single virtual machine. And with Jet, you always have your own virtual machine, but you can run as many containers as you want. So with Jet, if you go through the process of setting up your account, you'll actually be able to pick your build machine, so you can customize it to be as big or small as you want. And then you can be guaranteed that your build machine that you select and potentially that you pay for you'll always have the same specs, and then you can run as many containers as you want, as specified from your services and steps file. One last question, GitLab. So I think maybe is something, do we support GitLab? And sadly, right now, the answer is no, but it's something we get requested a lot. So it's definitely on our roadmap. Great, thank you very much, everybody, for spending the time with us this afternoon or evening. And look for a recording of this webinar via email next week. And we hope to see you next month on the 25th for Ethan's Introduction to CI/CD with Docker Best Practices webinar. Enjoy the rest of your day.